Hello guys, welcome to Maths by Budania sir. In this video, we are going to discuss case study question from the chapter Some Applications of Trigonometry. Here we will discuss the question and the concept involved. If you haven't subscribed the channel, then subscribe it and press the bell icon so you can get all the notification time to time. As we are going to discuss all types of questions, be it MCQs, assessment region, case study, descriptive 2, 3 or 5 marks. We are going to discuss all the important questions from all the chapters. Before starting the video, you should pause the video and try it yourself, then see the solution. Let's start. Here, case study says we all have seen the aeroplane flying in the sky but might have not thought of how they actually reach the correct destination. Air traffic control, that is ATC, is a service provided by ground-based air traffic controller who direct aircraft on the ground and through a given section of controlled airspace and can provide advisory services to aircraft in non-controlled airspace. Actually, all this air traffic is managed and regulated by using various concepts based on coordinate geometry and trigonometry. At a given stance, ATC finds that angle of elevation of an aeroplane from a point on the ground is 60 degree. After a flight of 30 seconds, it is observed that the angle of elevation changes to 30 degree. The height of the plane remains constantly as 3000 root 30 meters. Use the above information to answer the question that follows. Here we will be using this information to solve the questions. Above information is general information for your knowledge. So keeping in mind this information, we are going to solve the question. Okay, before proceeding to the answers, let us see the concepts to be used here. If in a right angle triangle you are given a angle and one side and you have to find the another side, then we will use suitable trigonometric ratio to find the side. For example, here we are given a triangle ABC whose side AB is 2 centimeter and angle C is 30 degree. From here we can say that this side AB is opposite to the given angle, so it will be perpendicular. Okay, and side BC is adjacent to the angle, then this side BC will be base. Okay, if we have to find BC, then we know that tan theta is the trigonometric ratio, which is a ratio of sides AB and BC. Hence, we will use the tan theta. Here, what we want to say is, if in this triangle, given triangle ABC, if we want to find BC, then we will consider the ratio which includes side BC and the given side AB. So we know that tan theta is equals to P by B. So P is AB and B is base is BC. From here we can easily find BC. Tan theta means tan 30 degree is equals to AB is given, that is 2, and BC is what we have to find. Now we know tan 30 is 1 by root 3. So from here we can say that BC is equals to 1 by root 3. If we cross multiply, we will get 2 root 3 centimeter. Similarly, if we have to find AC, then we will use sine theta. Here AC is hypotenuse. So, if we have to find hypotenuse, then we have to consider a trigonometric ratio which consists of perpendicular and hypotenuse. So, we know that sine theta is P by H, or we can also use cosec theta. Cosec theta is just inverse of sine, and that will be H by P. Here we will use sine theta. So sine theta is equals to AB by AC. So here AB is perpendicular and AC is H. Here theta is 30 degree. So sine 30 degree is equals to P by H. That is AB 2 by H is AC. From here we can easily find AC. So AC will be equals to 2 by sine 30. Sine 30 is 1 by 2. 2 will go in numerator. It will be equals to 4 centimeter. Similarly, if in a right angle triangle we are given one angle and one side, then we can find other two sides easily. One more concept that we are going to use here is speed is equals to total distance traveled upon total time taken. Okay, now let's come to the questions. First part is asking, draw a neat labeled figure to show the above situation diagrammatically. Here we are given that at some point of time, the aeroplane is making angle of elevation of 60 degree. Let's say this is 60 degree. Now after 30 seconds, let's say initially the plane was here and it is going in this direction. Okay. After 30 seconds, let's say the plane has reached this position. So now we know that the height of the plane is constant. The height of the plane remains constantly as 3000 root 3 meters. So here we can say that after 30 seconds it has reached this position. Now join this. Now let's say this is point A, B, C, D and E. And this angle is 30 degree. We are given that after 30 seconds, it is observed that angle of elevation changes to 30 degree. Here height AC is 3000 root 3 meters and DE is also 3000 root 3 meters. Okay, this is the required diagram that part 1 was asking us. Part 2 is asking what is the distance traveled by the plane in 30 seconds. So we know that in 30 seconds the plane has covered the distance CD. From above diagram we can easily see that initially it was at point C or it was at point A, and after 30 seconds it reached the point A. Means from C it has reached D. Now what we have to find is CD. Distance traveled by the plane is equals to CD. And we know that CD will be equals to BD minus BC. Okay, that will be equals to BD minus BC. Now here we can see that BD is the side of the triangle BDE. So we have to consider the triangle BDE to find the BD. So in triangle BDE, now in triangle BDE, it is given that this angle is 30 degree and this side is 3000 root 3. Since the side DE is opposite to the angle 30 degree, so we can say that this is perpendicular. And what we have to find is base. This is base. So considering P and B, we can use the trigonometric ratio tan theta. So here we will be using tan theta. So we know that tan theta is equals to DE upon BD. So tan 30 is equals to DE is 3000 root 3 upon BD. Tan 30 degree is equals to 1 by root 3 is equals to 3000 root 3 upon BD. So BD will be equals to, we cross multiply root 3, then we will get 3000 into 3, that is 9000 meters. Okay, we have got BD. Now what we have to find? We have to find BC to get CD. Now to find the side BC, we are going to consider the triangle ABC. So in triangle ABC, we know that we are given AC and we have to find BC. So AC is perpendicular because it is in front of the given angle, and BC is the base because side BC is adjacent to the given angle. Okay, now what we are going to use is in triangle ABC we will use tan theta. Tan theta involves the side P and B, so tan theta is equals to AC by BC. Now theta is 60 degrees, so tan 60 is equals to AC is 3000 root 3 upon BC. Tan 60 is equals to root 3, 3000 root 3 by BC. From here we get BC is equals to 3000 meters. And we know that distance traveled by the plane in 30 seconds is equals to CD, that is equals to BD minus BC, and CD will be equals to BD. We have already found that, that is 9000. 9000 minus 3000, that is equals to 6000 meters. So now we can answer this question in words. I am writing here only on the left side. Therefore distance traveled by the plane in 30 seconds is 6000 meters. Okay, now second or part is asking, keeping the height constant during the above flight, it was observed that after 15 into root 3 minus 1 seconds, the angle of elevation changes to 45 degree. How much is the distance traveled in that duration? Now we are going to use the same figure we have used in previous part, but difference will be that the angle of elevation has changed from 60 degree to 45 degrees. So instead of 30 we write here 45 degree. and all the other things will be as it is, because as plane is flying at the same height. So now what we have to find is CD only, because the distance traveled by the plane in required time is CD. So we will write here distance traveled in 15 root 3 minus 1 seconds will be equals to CD, and we know that CD is equals to BD minus BC. Now for BD we will use the triangle BDE. In triangle BDE, using tan 45 degree is equals to DE upon BD, because this is perpendicular and this is base. So tan 45 is 1, DE is 3000 root 3 upon BD. From here we get BD is equals to 3000 root 3 meters. Okay. Now next what we have to find is BC. For BC we will use the triangle ABC. In triangle ABC we know that tan 60 degree is equals to AC by BC. Tan 60 is root 3 is equals to AC is 3000 root 3 upon BC. So from here we can write that BC is equals to 3000 root 3 by root 3. Root 3 will cancel root 3, so we will get BC is equals to 3000. Now what we have to find is the distance traveled. So therefore distance traveled by the plane in 15 into root 3 minus 1 seconds, that is equals to BD minus BC, that is equals to BD is 3000 root 3 minus 3000 equals to, from here we can take 3000 common, so we will get 3000 into root 3 minus 1 meters, and this is the answer. Okay, now in third part it is asking what is the speed of the plane in kilometer per hour. Here for the speed of plane we can use data from the second part or its or part, whatever you are comfortable with you can use. I am going to use here is second part data. Okay, you can use or part data also. Now we know that distance traveled by the plane in 30 seconds. In second part what we have found is distance traveled by the plane 30 seconds, that was equals to, we have got the distance 6000 meters, so is equals to 6000 meters. So speed, as we know that it is equals to distance traveled upon total time taken. So speed will be equals to distance traveled, that is 6000 meters, upon total time, that is 30 seconds. Now see here what is asked is speed in kilometer per hour. So we have to change this meter into kilometer. To change it in kilometer we need to divide it by 1000, and to change this time from seconds to hour we have to divide it by 3600, and from here we can simplify this. 3 zeros will cut 3 zeros, 1 zero will cut 1 zero. Okay, 3 2s are 6, and this will go to the numerator, that is equals to 2 into 360 equals to 720 kilometers per hour, and this is the answer. Okay, here we end the video. If you like the video, hit the like button and share it with your friends so that they can also get benefited. Okay, see you in the next video. Bye bye.